All right, here we're looking at section 10.4. And our learning targets for today, we're going to find inverses of relations. Then we're going to explore inverses of functions. Then we're going to find those inverses algebraically. And then we're going to look at some nonlinear functions and see if we can find the inverses of those as well. So the first thing we're looking at is an inverse of a relation. So when a relation contains a comma b, the inverse is b comma a. So I just flip my domain and range, or my x and y. So here's our first example. We have to find the inverse of each relation. Okay, so I know that if I have this relation, then I just switch the coordinates of each ordered pair. So my inverse relation, I just switch the order of the pair that I'm given. So I can do that in either points or my table. Okay, so I just have to switch the inputs and outputs if I have a table. So now I have the inverse of my relation. So here are some for you to try. Really just think about these couple ones. So now let's look at an actual kind of function. Here we're going to solve y equals f of x for x, then find the input when the output is -3. So first thing I want to do is I want to set my f of x equal to y. So now I have y equals 2x plus 1, and now I know I can solve for that x value. So I subtract 1 from both sides, and then I'm going to divide each side by 2. So now I have x equals y minus 1 divided by 2. So now I can find the input when y equals -3. So my output, I was told, was -3, and the output was always my y. So I substitute in that -3 for y, and I can subtract and then simplify. So I know that my x value, or my input, is -2 when the output is -3. So here we're kind of looking at what we were doing. In the last example, these were the steps that I took. I undid the steps that were being done. So they were just done in reverse order. So inverse functions are functions that undo each other. So I had my original equation, and then I had my inverse function. Okay, so I could look at that too, and I could plug in my table of values. I could come up with some x values and find my f of x. Well, and then I could actually find the inverse and look at those. And you'll see here that the graphs of inverse functions share some common features that we're going to look at in just a minute. So now here are a few that I want you to try. First, you're going to be solving for x, and then find my input when my output is 4. So here's how I can find the inverse of a function algebraically, right, doing the math. First thing I want to do is I want to set that f of x equal to y. Then I switch my x and y in the equation, and then I solve for y again. So let's look at an example. So here I want to find the inverse function of f of x equals 4x minus 9. So the first step I do is I substitute my f of x for y. So then I want to switch my x and y around. So now I have x equals 4y minus 9. So now I'm going to solve for y. So I add 9 to both sides and then divide by 4. So my inverse function is x plus 9 divided by 4, or 1/4 x plus 9/4, right? And I can write it this way because this is an easier function for me to graph than this one is. So I can look at that way. The other way I can do this, I can use my inverse operations in the reverse order. So I can multiply, here I see I multiply the input by 4 and then subtract 9. So to find the inverse of this, I would do the inverse operations in reverse order. So I would start by adding 9 and then dividing by 4. This can get a little more complicated, so I really want you to focus on this first method here. So now here's some for you to try and see how you can do, and if you can graph them both and see if you notice anything about those graphs. So now here we're looking at a nonlinear function, right? Because I've got x squared, f of x equals x squared. But I'm looking for x is greater than 0. Then I have to graph the function and the inverse. So the first thing I want to do is I always write my function. Then I substitute my f of x and y. Then I switch my x and y in the equation, and I take now the square root of both sides because I'm solving for y. So I see here that y equals plus or minus the square root of x. So my domain was restricted up here to x is greater than 0. So the range must also now be restricted to be greater than or equal to 0. So here's my function. Okay, so my original function, this f of x, is drawn in blue. So we can see it's just a pretty normal quadratic, but it's restricted to the positive domain, right? Only x is greater than 0. So here I'm restricted, my red one, this is the inverse of that function. So now we're going to look at the horizontal line test. So horizontal, remember, meaning going across. So the inverse of a function is also a function if and only if no horizontal line intersects the graph more than once. So what I think of when I see this is I think of a general quadratic, right? My quadratic looks kind of like that. So if I'm looking at a horizontal line, right? Horizontal means goes across this way. So here I see that I intersect my graph in 2 places. So I know that the inverse of this function is not a function because I do not pass the horizontal line test. So now I'm going to look at this function. F of x equals the square root of x plus 2. So determine whether the inverse of f is a function and then find the inverse. So the first thing I want to do is I want to graph my function. So here I've got my square root of x minus 2. And then I look at my horizontal line test and I see that there's no place on this graph where a horizontal line will touch the graph more than once. So the inverse is a function. So now I can find the inverse. So I substitute my y for my f of x. I change my x and y. Then I square both sides because I'm solving for y. And then I kind of simplify that and then I subtract 2. So because my range is y is greater than 0, the domain of my inverse function is going to be restricted, so x has to be greater than 0 as well. So I have to keep that in mind when I'm looking at inverse functions, is my restrictions on the domain and range. So here are a few more for you to try and think about. First, can you determine, is it a function? Does it have an inverse? What is the inverse? So now let's look back at our learning targets. So the first thing we did was we found inverses of relations, and this is when we were looking at either some coordinate pairs or a table of values. So then we explored some inverses of functions. Then we looked at how to find the inverse functions algebraically, and then we looked at some nonlinear functions. And the big thing when we're looking at nonlinear functions is I have to restrict either the domain or the range to make them both functions. So now that I've worked on the learning targets for 10.4, go ahead and work on your homework.